Today's lesson is on mole-mole problems, and we're going to use our balanced equations to do this. So remember in class, I'm sure you don't forget, that we exploded the nitrogen triiodide. And here's the equation for nitrogen triiodide exploding, and it makes nitrogen gas and iodine gas. And here's the balanced equation. You can see that we have 2 nitrogens on both sides, 6 iodines on both sides. So what do these coefficients really mean? So we have 2, 1, when it's nothing there it means 1, and 3. So what do they mean? Well, you can take 2 molecules of nitrogen triiodide and it will make 1 molecule of nitrogen gas and 3 molecules of iodine gas. But usually we're not working with something that small as a molecule at a time because we wouldn't even see it. So these coefficients can also stand for moles. So if you take 2 moles of nitrogen triiodide, you will make 1 mole of nitrogen gas and 3 moles of iodine gas. So on the worksheet you did the night before, I gave you the mole-to-mole equivalencies, and now you should be able to get them yourselves. So if I have 2 moles of nitrogen triiodide, that is going to be equal to 1 mole of nitrogen, because that's the coefficients from this balance equation. There's a 2 here, and there's a nothing here, which implies 1. So 2 moles of nitrogen triiodide will produce, that's what the equal sign means here, will produce 1 mole of nitrogen. We also know that 2 moles of nitrogen triiodide is equal to, and here the equal stands for will produce, 3 moles, because that's the coefficient here, 3 moles of iodine. And the last pair we haven't talked about is what about comparing nitrogen to iodine? Well, if I have 1 mole of nitrogen made from the explosion, I will also make 3 moles of iodine. So anytime you make 1 mole of nitrogen, you also make 3 moles of iodine. So let's use these to solve some problems. So I've set some up here. So here's our equation again. And the question is, how many moles of iodine are made when 65.3 moles of nitrogen triiodide explode? So we use our same problem-solving skills, and we're going to start with what are we looking for? And that's moles of iodine. So I'm going to write equals moles of iodine. And the other side, I'm going to start with what I was given, which is 65.3 moles of nitrogen triiodide. So 65.3 moles. And don't forget to put moles of what? Because we have moles of iodine and moles of nitrogen triiodide. We can't mix them up. So I have to write moles of nitrogen triiodide and not leave it just as moles. We're going to put that over the number 1. And now I have to convert moles of nitrogen triiodide to moles of iodine. And so to do that, I'm going to use this balanced equation. I need the moles of nitrogen triiodide to cancel, so I'm going to put that on the bottom. And if you want to use the abbreviation, which isn't much of an abbreviation, but the abbreviation for moles is just MOL. So I'm going to use that here. And there's a 2 in front of the nitrogen triiodide, so 2 moles of nitrogen triiodide will make 3 moles of iodine. And now moles of nitrogen triiodide cancel. I'm left with moles of iodine. I wanted moles of iodine. So now I need to get out my calculator. So I'm going to do this on my computer here. And I'm going to take 65.3, multiply by 3, and divide by 2. And I get 97.95 moles of iodine. But I have to remember significant figures. And I have 3 significant figures here. These don't count for the significant figures because these are exact numbers. So I have 3 significant figures, 97.95, so I have to round up. So that gives me 98.0 moles of iodine. All right, so there you have it. Let's try one more, and I think you'll get it. So still using the same equation with our nitrogen triiodide explosion, the problem reads this time, when you make 3.9 moles of nitrogen, how many moles of iodine are also made? So I'm going to once again, what am I looking for? Moles of iodine. So I'm going to start with equals moles of iodine over here. I'm going to start with what I was given, which is 3.9 moles of nitrogen. And I'm going to put that over the number 1 so I remember that it is a fraction. And now I have to get rid of moles of nitrogen and get moles of iodine. How do I do that? I use my balanced equation. So what number is in front of the nitrogen? No number. So that implies a 1. So for every 1 mole of nitrogen that I make, I also make 3 moles of iodine. 3 moles of iodine. And now moles of nitrogen cancel. I'm left with moles of iodine. So I get out my calculator and I will plug in 3.9 multiplied by 3, and I get 11.7. And once again, I have to go back to significant figures. I only have 2, so this rounds to 12 moles of iodine is my final answer. So pretty simple problems. I hope you get them. Give it a try with the problems. Thanks for listening.